everyone, welcome back to my YouTube channel. Still on programming with C++, and today we'll be treating expressions and statements. Alright, so our objective at the end of the lesson is to know what statements are, the types of statements, what expressions are, and the types of expressions we have in C++ programming language. Let's get started. Now, when we talk about expressions are the combinations of variables, operands, and operators. So, combining variables, operands, and operators, we get an expression. Now, variables or they store values or results of expressions. So, they store the value or the result of expressions. For the operands, we say they are the entities that operators act on. So it represents the data in an expression. The operands are the entities that operators act on and they represent the data in an expression. For the operators, they are the mathematical symbols used for specific operations. So that's the addition, the multiplication, and what have you. Yeah, when we can say an expression may consist of one or more operands. It may consist of zero or more operators to produce a value. So, this is some example. So A plus B. So this is an expression with an operator to produce a value, right? So for the second one, we have only C, but it's also an expression. We say it may consist of what, zero or more operators. And for the last one, we say x is equal to a plus b. So what this means is x is the variable here, is storing the value of the sum of a and c, right? So x is a variable, the equal to is the operator, one operator inside. The a is the first operand, the plus is another operator, and the c is the next operand, right? So this is basically what I was saying. So A is the first operand, the plus is the operator, and the B is the operand. So operands are just basically the value that the operators act on to produce a value. Now we have types of expressions. We have the constant expressions, we have the integral expressions, the bitwise, pointer, logical, relational, and floating point. And we'll be dealing with some today. Okay, so we say if all integers or if all operands are integers as the values, right, that in which the operator acts on, if they are all integers, we say that expression is called an integral expression. Same way, if all operands are floating points, we say that expression is a floating point expression. Now note, an integral expression yields an integral result, and a floating point expression yields a floating point result. Right. For mixed expressions, we say it has operands of different data types, right? It contains integers and floating points. Examples of mixed expression, does it. So it has operands of different data types. That's, you can have maybe an integer data type, summing a floating point data type. So that's what mixed expression is. So operands of different data types. So this is basically an example. So we say an integer, that's 2, then the operator plus, then the floating point value, that's 3.5. So the second one to deals with same, so 6, 4, then 6 divided by 4 plus 3.9, and so on and so forth. We also have conditional expressions. We say expressions where the value produced depends on the value of a condition. So this is where the value produced or being, that's the result of that values depends on the value of a condition. So let's check out what that condition is. Right, so that's basically the conditional expression. So it's where the value that has been produced depends on the value of a condition. So when you're given a condition, right, whatever that condition is, that's what the results you get. So it depends on that condition. Whatever result you get is based on the condition you were given, the value of a condition. Right. So moving to relational expressions, we say they yield results of type bool, which takes a value true or false. I said in my previous videos that bool, which is boolean, takes either a true or false, a yes or no, or one or zero. And actually, true represents either a yes or a one, and false represents either a no or a zero. So that's basically the relational expression. So this is the it yields results of type bool. There's a boolean data type, right? So an example is this. We see a less than sign with an equal to sign then y. So this is telling you that x is less than or equal to y. This is how we write it in programming languages. And we also see x plus y is greater than 2. So this is or these are boolean or relational expressions. For logical expressions, we say they combine two or more relational expressions and produces a bool type result. We said earlier that relational expressions are based or are Boolean type, they are Boolean data type. So for the logical expressions, they combine two or more expressions and they produce a Boolean type result. So some examples include this, right? So in our programming, we say that the and for here it's not known as the address of operator, but it's known as the and, right? And the two equal sign means equal to and not assignment operator. So that's and for the yeah, so basically this is how we say in logical. So this is a combination of let's say two or more relational expressions, right? So this is a logical expression combining two or more relational expressions to produce a bool type. So when you have to solve this and in programming, you're going to get a bool type result. We also have pointer expressions. We said the produce address values. We know, or I said earlier in my previous video that pointers are they are variables, right? And they store or they produce the address of other variables. So pointer expressions is basically producing the address of values, right? Or address values of other variables. This is also an example of how you can write it, get it done. Now for ending expressions, this one tells the system that you are done with your expression instruction or expression creation. So with the ending expression, you're telling the computer system that or system that you are done with the instructions you gave it to work with. So it can now display or output whatever you want it to run for you. And we use a semicolon symbol to mark or show the end of an expression. That's also known as a termination symbol. So it's used to end an expression or to show the end of an expression. So this is also a basic C++ program of an ending expression. So here this is known as initialization. As I said in my previous video, we've assigned the values to the variables. So first we told the computer system that, or the compiler, that the age is of an integer data type, an integral expression, right? And we assign the value 12 to it, that it stores, or it has 12 in its inside of it, and we terminated that's the end of our expression. For the next one, we say the variable x, which is of a string data type, was assigned ama, and we terminated, showing the end of the expression. So the semicolon is used to end an expression. We move on to comments. We use comments to make reading and understanding programs much more pleasant. So comments are just they are not really a programming or program codes. They just make reading and understanding programs much more pleasant, right? So comments are helpful in skipping the execution of some part of the code. So if you want to skip the execution of some parts, you can actually comment, showing that you are skip, and this helps in or makes reading and understanding the programs you are uh, coding or programming much more pleasant. Comments are used for easier debugging. So if you want to debug, comments are best things to use, right? So we have types of comments, the single line comments and the multiple or the multi-line comments, right? So for the single line comments, we say it applies comments to a single line only. So that's only one line of code is the comment applied to, right? Now we see also that the compiler ignores any text after the single line comment, which is a double forward slash, and it will not be executed. That's why I said it doesn't recognize it since it has been commented, right? And comments are not to be executed, right? They just help reading or understanding the program much more easier. Now we use the double forward slash to represent a single line comment. So this is also how we make a single line comment in a basic C++ program. So on that line of code, then you put the forward slash. So let's say hello world, you can say while the first in a single line comment, you can actually input my first programming with C++. Then you comment it, a single line comment. Right? When you display, you're not going to see that, but you're going to see the hello world since the compiler ignores any text or codes or words after the double forward slash. Yeah, so this is how we use a single line comment, right, on that line of code. So for the multi-line comment, it occupies many lines of code. As it doesn't take just one line. It can take from maybe from line one to wherever you want it to end. So it occupies many lines of code, and we use the forward slash and an asterisk, then ending it we use the asterisk and the forward slash again, showing the multi-line commenting being done in your program. And as I said, the compiler ignores any text between these comments, like the slash and the asterisk and the asterisk and the slash. So it ignores anything inside or between the comments. There's also a multi-line, a C++ um, program of a multi-line comment, right? So the multi-line comments, which will be ignored by the compiler, they are inside this comment symbols. Now, when we talk about indentation, we say it makes code readability and understanding much more pleasant, right? Each nested block should be properly indented and spaced with a tab space. If you watch my previous videos for the practical session, I like to leave a space before I go to the next for a pleasant or a presentable work, a neat work. So indentation actually makes code readable and understanding much more pleasant, right? And if you have, let's say, a nested block program or code, science of codes, they can also be properly indented and spaced with a tab space, right? So all braces should start from a new line, then the code comes following the end braces from a new line, right? That's a curly braces. That's if you want to input a curly brace in a C++ program language, you say you start it on a new line, then the code comes following the end braces from a new line as well. So indentation is mainly used for code inside looping system and control structures. So codes that are to loop, let's say a program or a function or something or a statement, that's when indentation is mainly used and for control structures. It can also be used in functions where the loops and control structures are used in them, as I said as well. This is also a C++ basic program of it. So this is a control structure. That's the if statement, right? So we initialize two variables, then we say if this is this, then display this for me, right? Now we say a statement is a single instruction that performs an action. Statements are the building blocks of a C++ program. So they are the instructions that are to perform an action, and they are the basic building blocks of a C++ program. We have types of statements. We have the selection statements, which are used in decision making. That's the if or the switch statement. We also have the iterative statements. They are used to express iteration of tasks. That's the for, the while, and the do while loop. Right. And we have the expression statements, right? They are the statements used to evaluate expressions. We also have the declaration statement. That statements are used to introduce new variables or constants. For example, we declare variable, say age, of the data type integer, then we terminate. So this is a declaration statement. You're introducing a variable or a constant in your program. For the jump statements, we say they are used to manipulate normal execution of codes. Example is the break, the continue, and the go to. We have the compound statements. They are statements that group multiple statements together, and they are blocks of code enclosed in curly braces. So they group multiple statements together, and they are blocks of code enclosed in curly braces, right? So this is basically a compound statement. Codes are grouped together and they are enclosed in a curly brace or braces. Right? So for the selection statements, we say it's used for decision making in C++. That's the if and the condition, then the statement, or the if and the condition and the statement, and the else statement, right? Then we also have the switch, then the condition, then the statement. Note, a condition is either an expression or a declaration, right? So this is also a diagram showing the decision-making statement. That's a selection statement. So the if else is if, the nested if, the switch, and so on and so forth. For the if statement, it's a mechanism for deciding whether an action should be taken, right? So this is basically helping you to decide whether this action should be taken or that should be taken. So the if, then the expression, then your statement be given. This is also a C++ programming language. We say we initialize the variable age, and we say if the condition is that if age is greater than 18, so if the user or the person who is using it is greater than his or her age is greater than 18, then we are telling the compiler to display that students can vote, right? This is also a basic C++ program of a basic if statement for you. Right, now using indentation for the if statements, so this is how we use it. Then we initialize the variable, then we give the if, then the condition, then the statement. You can see every line there is a space showing the indentation. For the if else statements, it can be used to choose between two conditional statements. So the if, then the expression, then your statements you give, right? Or the else actually means if it's not what you said earlier, then it should be the one you want or you're bringing next. So here too, we initialize a variable age. We're still working with the age, and we say if the condition given is if age is greater than 12, right? The compiler should say the student is old. Else, if age is less than 12, the age being, or the user inputs is less than 12, it should say the student is young, right? For the nested if statements, we say they can be used to choose between conditional statements with nested conditions. I forgot to say this. I'll actually be giving more tutorials on the practical session after I'm done with this theoretical session. So stay tuned, don't go anywhere. For the nested if statements, it can be used to choose between two conditional statements with nested conditions. So just like the if-else statement, they are conditional statements, but the nested if, they have nested conditions to read as, let's say if, then the expression, then if again, then the expression, then your statement, your final statement. So this is also a basic C++. We want to use indentation for proper understanding or making understanding much more pleasant. So we say if, let's say, a variable n is greater than 0, right? And if that variable n is of the modulo or 2, right, is equal to 1, then we should display positive odd numbers. So you are saying if the value n is greater than 0, right? And if that same variable, the modular 2 of it is equal to 1, then display positive odd numbers. So this is basically a nested if. Then when you're done, you can also bring else positive even numbers. So if it's true, then you display a positive number, else you display positive even number. So this is a nested if statement. Okay, so using code block, the code block is a software, right? A compiling software where we can use to program all the C++ programs through it. So basically what I said, so if n is greater than 0, then if that modulo 2 of n, that variable, is equal to 1, then the compiler should display their positive odd numbers, right? Else it should display their positive even, or sorry, negative number or 0. We also have the switch statement. It allows you to, we are dealing with the selection statement. So the switch statement it allows you to choose between multiple alternatives. It compares the value of one expression with multiple constants. Expressions in switch statements must be an integral type. So the expressions inside must be an integral type. Now when we say it should be an integral type, it doesn't necessarily mean it should be an integer data type. No, an integral type can be the integer, the character, the boolean, and so on and so forth, and not the user defined data type, right? So we say the constants must be different and can only be integral types. So this is also a program, a C++ program of how to use the switch statements or expressions in it. So we say the switch, then the condition of the expression, then we say case. So switch actually move with case. So if the first case, then your statement is, if the first case is this, then you break, right? So the break is actually the jump statement. Then you move to the second case, then you break till you're done with the number of cases you want to do. Then you can use a default telling it that the statement or the value the user inputs is none of the above cases. So the user should input a value that's within or of any of the cases or the conditions given. So this is declaration. Let's say we declare, no, we initialize the variable age, right? Then we say the switch statement, then the case, then the statements, then break, then your default statements, then you break. Yeah, so this is a C++ programming language. We say let's initialize the value age to be 12. Now, Let's switch age, right? So we switch age saying that age is a condition. That's if the case is 18, then or if that case is 18, that means the value the user inputs is 18. We should output or display that the students can vote. Let's say it's a voting system. So the user inputs 18, we will display students can vote. Then you break then your default statement. You can actually say the value inputs is not within the range given or the condition given. That's actually the default statement. So it's actually prompting the user to choose or select or input any of the conditions given. So if it's more than, then you can actually go back, then input the right thing. So default, then students can't vote, right? Then you break. So the break system exists from a switch or loop immediately. The break keyword can be used to jump to the first statement that follows a switch or a loop. So it can be used to jump to the first statement that follows a switch or a loop. Right, so this is also the break as we've been using. So we say okay, so when we omit the break keyword from there and we just bring see how students can vote, default see how students can vote. Actually, when you have to display this, right, the compiler is going to display both see how students can both students can vote and students can vote. Since you didn't ask it to break, like to stop the how should I put it, the to stop the switch case, right? So the break is used to end that switch case, yeah, to stop it, right? Now for the continue statement, it's continuous execution after a condition is accomplished. It's used in loops and it has the opposite effect to break. It has the opposite effect to break. That is, the next loop is begins immediately. So here, instead of the break, we use a continue, right? Then we say students can vote, so continue. Then students can't vote, then you break. So both will be displayed for you when you run the codes. Now, the operators we spoke about earlier, they are the mathematical symbols used for specific operations. That's the addition, the multiplication, the less than, and so on and so forth. Right? We have types of operators. We have the arithmetic operators, we have the assignment operators, we have the conditional operators, we have the relational operators, we also have the logical operators. For the arithmetic operators in C++, we say this is for addition, subtraction, multiplication, division. Now, this percentage sign we see here is actually known as the modular operator or the remainder, right? So they can be used with an integral and floating point data types. Now we have also types of operators under this type. We say we have the unary operator, that is has only one operand, right? And we have the binary operators, it has two operands, and the ternary, it has three operands. For the logical operators, it's used to express logics. It returns a bool result. So it uses the and, the or, and the not operators and all of those, right? So expression operator variables. So this is also how to express a logical expression, logical expression in C++ programming language. So this is known as the and, right? So let's say we want to give a condition, right? We want to use the if statement to give a condition, and we say we've initialized the variable age already to be 12, and we are saying if the user or the user's age, the value that the age the user inputs is greater than or equal to 12, And if age is less than that, is between, is in that range. And if that age is less than and equal to 18, then you display the students can vote. Right? So if the age the student's input is within this range, then you display, the compiler displays that the students can vote. So this is the logical operator, or it's also using the if state, that the selection statement. So we initialize the variable age again, and we say if that age, so this equal sign I said here, two equal signs are known as a equal to sign, and just one equal sign is known as the assignment operator. Right, so if age is equal to 18 or the age is greater than 18, you see how the students can vote. So whatever age the user inputs, if it's equal to 18 or is greater than 18, then we instruct the compiler to display that the students can vote. This is also the logical operators not, right? So also we are still using the selection statement for it, and we say if the age is not equal to 18, we say the student can't vote. So you can actually combine all these programs, the and, the or, and the not together to produce a whole selection statement. So that would be called a nested if, right? If you combine both the not statements with the, or the not operator statements with the or and the and, we get a nested if statement, right? For the conditional operators, we say it's used to form an expression that produces either of two values depending on the value of some condition. So they form an expression that produces either of the two values depending on the value of some condition. So the syntax, or the how it's programmed, is the expression, then the expression. Yeah, so like we're saying results equals, right? So it stores or the values of uh the value of some condition. So result equals to x is greater than or equal to 0, right? For the conditional operators, this is how we can input it in a basic C++ program, right? So the conditional operators versus the if statement in a C++ program. We say that's where we use the if, the max, and the else. So if A is less than or equal to B, then and max is equal to B. Sorry, if A is less than or equal to B, then max is equal to B. Else max is equal to A. So whatever value the user inputs, that's what you're going to get. So you're trying to tell it that you're telling the compiler that if the user inputs that A is less than B, then there should be, the display should be that max is equal to B. Else then max is equal to A. So we're still under it. So this, we can also use what I just said there. The max is equal to, then the A is less than B. So your question mark then the B, then you have it there. Now we also have the increment operators. So this is used to express increments in a value. It can be used as a prefix or a postfix operator. It uses the plus plus operator. So this is known as the increment operator. You're adding a value to the operand. So the syntax is the operator and the variable, right? So the prefix, so for the prefix increment, that the increment comes before the variable before you terminate. For the postfix, it comes after the variable, then you terminate. Yeah, so this is a C++ program. We're using the switch case for it, and we say let's switch the A. If the case is 18, the students can vote. Break, the students can't vote, right? Then we can add let's say plus plus to it, then we terminate and break. So for the decrement operators, they are used to express decrements in a value. They can be used as a prefix or a postfix operator, and they uses the minus minus operator that's known as a decrement operator. So it's basically the same structure with the increment, the operator, and the variable. For the prefix increment, we say the decrement operator, then the prefix decrement, sorry, we say the decrement operator, then the variable, then it terminates. For the postfix, the variable, then the decrement operator, and then you terminate. So this is actually saying subtract the subtract the value before you display for the prefix. So subtract, let's say 1. So you're saying subtract 1 from the variable before you display it. But the postfix is saying display the variable, then you add or you subtract 1 from it. So first you display the variable, then you subtract 1. But from the prefix, you subtract before you display the value of that variable. So actually what's to be displayed is what has been subtracted. That's for the prefix decrement. So we can also use them in a switch case like this one. Now we say we have the operator precedence, right? So this is actually a rule we follow. So all operations inside of the parentheses are evaluated first. Note, so it's a precedence, right? All the operations inside of the parentheses are evaluated first. Just like we have in mathematics the BODMAS, in programming we also have the PEMDAS, that is the parentheses. If there is an exponent inside, then the exponent, then the multiplication, the division. If there's a modulo, you also add it. Then before the addition and the subtraction comes. So the all operations inside of the parentheses are first evaluated. Then if there is a multiplication or a division or a modular operation, then that's what you evaluate next. So mostly they can also be at the same level of precedence, and that's what is evaluated next after the operations inside the parentheses. Now after the multiplication and the division and modular, we also have the subtraction and the addition. They have the same level of precedence and they are also evaluated last. Now when operators are on the same level, we say we performed they are performed from left to right. So when both operators are on the same level, they are performed from left to right, right? So we start from left to right. So this is basically so I want to give you guys a task from what we've studied from lecture 1 to this lecture. I would like to use that knowledge to create or build a GPA calculator and a desk calculator. You can actually drop your codes in the comment section, and I'll be glad to give you a feedback. Thank you all. This is the theoretical session. Now let's dive into the practical sessions to understand more of what this is trying to say. Thank you. Alright, so welcome back. This is the practical session of the expressions and statements. So let's dive into it. Right, so beginning, we started with expressions and we said it's a combinations of variables, operators, and operands. Right, so an operand could be, say, 2, right? And the operator does addition, the subtraction, the multiplication. No, the multiplication is the asterisk in programming, right? And the division, which is a forward slash, and also the we can have the percentage for the modulo, right? So the percentage can be for the modulo. Yes. So let's try to do, so let's say I want to do an integral expression. So we first initialize a variable, say age, right? So let's say age, Then we assign, this is not equal, assign, we assign 12 to the age and we terminate, right? Then since I want to do it an integral expression, right, I can just assign another value, say just get, right, equal, sorry, I assign 23 to it and I terminate. Right, so now if we want to display, say, the sum of the two, what we're going to say is so I want to use the comments, that's a single line. Since I'm working on, I want to use it on just one line of code, so I want to use a single line comment, right, to make my program understandable. So let's say now I want to find, say, the sum of the two variables, the sum of age and get. So we say to make it understandable, my program understandable, I say finding the sum, right? So remember, the compiler ignores any text after the single line comment. So under it, so let me make, so this actually indentation, right, creating space and making your word also much more pleasant. So now finding the sum, we want to know what age and get will give us. So we say the age, then the addition sign, then the get. Then remember, always you terminate, showing that you've ended the expression. As I said, we end expression with a semicolon. Right. Now we want the compiler to display what the sum will give us. So we say out, right? Let's say we want to see, and say the age is. So now, how do we get the age? So we are telling the compiler that display the age, or sorry, the sum is rather, sorry. Display the sum of the two value is. So when we add 12 and 23, we're actually going to get 35. So how do we get that 35? Because if we run this, we're going to get an error. So how do? We say the sum is 35. So where you are going to input that 35, you just say age, you repeat this line, so you repeat this line here, and you say the age plus the get, right? Then you bring your operator. So this is saying that display the sum of the two ages, getting and how you get it from the sum over here. So you're telling it to display the sum of what you got for the two ages. So that's when you added this age, right, to the get, whatever you got, you display it over here for me. So now what I added is stored in this line of code. So that's why we repeat it here, so that it will process or display the value which was stored here. So this one, you say out the sum is. So instead of bringing 35, we bring the variables that were initialized. That's why we did it this way. And let's run it and see something. Right, so this is basically what I was saying. So the sum is 35. So adding to find the sum, we bring the age where we added that line of code. So that's what we'll bring over here. So that's, we are getting the age from it, right? And that's what we'll display for you. So this is how we make an integral expression in C++ programming language. Now let's check with the floating point expression. So I'm going to teach you how to do a multi-line comment. So let's say I'm done with the integral expression and I want to teach the floating point expression. I can actually come here, then I comment. I told you commenting. So when you're done with this is the multi-line comment, right? When you open it, so this actually, you've opened the multi-line comment, you're supposed to end it. You're supposed to let the compiler knows where the multi-line comments, and so that those texts in it will be ignored. But if you leave it like that, whatever you repeat over here, whatever repeats after the multi-line comments, right, will also be ignored. So I want to end it over here, so I'll bring this. Right now you see my return zero is working perfectly. So now for the floating points, so I can make here floating points expression, right? So for the floating points expression, same way as we did floats, we use a float data type, right? And not the integer, since we're dealing with the floating points expression. So the float data type, let's say a variable just d, then we assign the value 2.3. Note float is a decimal number, right? And we also assign, say, f, like a variable f, then we assign let's say 3.2. Yeah, then remember you always terminate showing you've ended the expression. So this is basically ending expression. What ending expression is, uses the semicolon to show the end of the expression, right? Let's say we want to get the sum of these variables, right? So we say d plus f, then we terminate. Right, now we want to get the compiler to display the sum, that's the d plus the f. So what we say is see out the sum is, right, the sum is, then over here we say get that sum we are talking about from this code, or this line of code. But here we don't terminate it, over here we terminate after the end line. So let's output this one too and see. So we're supposed to get something like 5.7. So yeah, so this is also how to do the floating point data type, the expression. Now with the mixed expression, I'm going to multi-line comment this. So I want to end it here. For the mixed expressions, we say they are variables of different data types. So mixed expressions, right? So they are of different data types. So one can be an integer data type and one a float. So let's say integer, then let's say 34. Integer is a positive or negative whole number. Then we terminate. Sorry. I should have brought a variable. So let's say a variable s. Then we assign the value 34 to it. Then we terminate. Then we declare or initialize a float variable, say d. Then we assign the value 10 to it. Then we terminate. Right. So now we want to find the sum of these variables s and d. We say s plus d. Then we terminate, showing the end of the expression. So this is also an expression. The s is the first operand, the plus is the operator, the d is a second operand, then the semicolon is showing the end of the expression. Now we want the compiler to display what this sum will give us, or is. So we say see out the sum is, right? Then inside here, this is where the sum of the two values are stored. So that's why we repeat it here. So it's like we're extracting the sum from that expression. Then we end it, right? So we get them like 44. Right. So this is also a basic C++ program on what I was saying. So this is the mixed expression, the floating point, and the integer expression. So this is basically all about the expressions. Actually, the other types of expressions, the logical, the relational, I'm going to teach them inside of the if statements, right? Inside of the statement. So don't be bothered about it. I'll come back to it, right? So let's say this is where we end the expressions, right? We move on to the statement. Now, for the statements, we like to begin with the if statements, right? So first, we say, let's say we initialize say age. Let's say we initialize a variable age to be 12, right? Let's say 12. Then we terminate, right? Then we say the condition is if the user inputs a value, if the user should input a value greater than age, then we should output something for the user. Else, if the user inputs, okay, we're not dealing with the if else. So this one is actually just one. So let's say we say if now if the age being the value of the age, right, is greater or equal to 18, then what do we say? So if it's greater or equal to 18, then we bring the curly braces. That's where our work should be done. So if it's greater or equal to 18, we should instruct the compiler to output what the students can vote, right? So this is just an if statement. So if the age value being input was greater or equal to 18, then we display students can vote. Now with the if else, we say what if the students input the value or a value less than 18? So what do we say? We just say else, right? Then the parenthesis, else the compiler should see out students can't vote, right? So let's try to so first we have to receive the data or the value from the user, right? So in some cases we can actually let the user input his or her desired value, right? But here we've already initialized a variable to be 12. So when we output this, we are going to, the compiler will display the students can vote. Since we said the condition is if and only if the value being given or assigned to the variable is greater than or equal to 18, then the compiler should output the students can vote. Else means that if the student or the age is not greater than or equal to that, is less than 18, then the compiler outputs the students can't vote. So let's run this and see. We initialize 12 to the variable age, so we have to get students can't vote since it's less than the condition given. So right, this is how we do the if else statement also. But I can actually comment this, right? Let me bring this on the next line and just give a multi comment for this. And let's run only the if statement to see what we'll get. Right, now you see nothing process because the condition was if age is less than, sorry, is greater than or equal to 18, then the computer displays the students can vote. That means if the age being input was or is less than 18, then it's now, because you didn't give it any other condition to display. So when you bring the else, you're telling it that if the age the value for the age given is greater than or equal to 18, then display the first statement. But if not, if it's the other way round, then you display the next statement. So this is basically the if else statement. Now for the if the nested ifs, so first let's multi-comment this, right? Multi-line comment. Now for the nested if, so you say nested if or if statements. So the nested if statements, right? Let's initialize, say, a variable n to be 1. Then we terminate. Then we say if the variable, so this is the condition, if the variable n is greater than 0, right? And that's the compiler should do something. But for the nested if, we are bringing more ifs in it. So we say if the variable n is greater than 0, and if it's also true that the variable n is greater than 0 and the 2 modular n is equal to 1, right? Is equal to 1, then there should be something. The compiler should display what? Say let's say coming. So we say so we should ask it to display, let's say, a positive odd number, right? Then this is where you bring the else display. So it also has to be in the curly brace. So else display was a positive even number, right? So I'm going to indent my work, so just for clarity. So yes, so we are saying if the value n, right, is greater than 0, and that's saying the 2 modular 2 of the value or the variable n is equal to 1, then if both statements are true, then the compiler should display that this is a positive odd number. Else, that if one is wrong and one is true, it should display a positive even number for us. So we're going to run this code and see what we'll get. Remember, I initialized n to be 1, and I said if n is greater than 0, that's 1. So you see, it's a positive odd number. So this is saying if n is greater than 0, that's 1, 2, and the others, right? And then the 2 modular n is equal to 1, then the compiler should display that variable is a positive odd number. Else, if I should put, say, 0 here, because I initialize n to be 1, that's why it outputs positive odd number. So let's say 0, right? Or a negative number or something. Let's just use 0 and see what we'll get. So a positive even number. So it says if it follows both conditions, then you display the first statement. Else, if one condition is wrong, or if it's one condition doesn't follow one of its conditions, we display the second statement. Or if both conditions are not in accord, or it doesn't follow both conditions, we display the second statement. So this is basically the nested if statement, right? So we're moving on to the switch case, right? So let me multi-line comment this. This is a multi-line, so I comment this, right? So for the switch case, we say, so the switch. So note the switch is also a selection statement, just like the if statement. So it's going to actually do what the the if statement did, but its structure is different, or it differs from the if statement. So right, for the switch statement, we say let's initialize a variable, say age, to be 12, right? Okay, 13. Then we terminate. Then we say switch. That's, we come to the next one and say switch, right? So we are saying if the age here, so the age. So what's the condition, right? So now, what the switch age means is that we are going to work on the condition age. We're going to work on the variable age. So actually, we're going to say switch always goes with a case. So we're going to say if the first case, or if say a user inputs 18, that's if it's of the case that the user inputs 18, instructs the compiler to display what that student can vote can vote, right? Sorry. Right, then we break, then you terminate. So we say switch, we're working on the age, right? So if the user inputs a value for the age, say 18, then the first case, you say, you tell the compiler to display that the students can vote. Then you break that statement. Break means you've ended that statement. Then you bring your default. So default is if it's not of the first case, right? Then you instruct the compiler to output what student can't vote. Right. So this is then when you're done with this, then um you break it also as well, saying you're done with your statement. Right. So indentation is very key. So as you saw, I left a space after I initialized the variable. Then this is where my statement was, or is, done. And I also left a space after I was done with my statement. And note the, sorry, there's a mistake. So when you're done with the statement, you have to close your curly brace, right? So here I initialize age to be 18, and since it didn't follow the first case, so the first case is actually the condition. So it's saying if the condition is that the inputs, or the input value for the age is 18, then the compiler should display the students can vote. But since we initialize age to be 13, it's displayed what students can't vote, since it didn't follow the condition. Now let's try making it 18 and see what we'll get. Right. So this is also how to perform a switch case in C++ programming language. Now with the break statement, we say a break is used to jump to the, it's mostly used in loops or in statements. So let's try omitting this break here and see what we're going to get. And let's omit this one too. Now let's run this and see. I initialize the age to be 18, right? And I said if the case is that the value is 18, then it should output what student can vote. So why is it bringing both conditions? So this is where the break helps. So when you're done with this statement, you tell the compiler to what? To end it, right? So that means if the condition, or if the value follows the condition, then it should only display this first the first statement. But if you omit the break, then you're saying it should follow the first statement and it should also follow the second statement. But when you bring the break keyword, yeah, making the compiler aware that when you're done or when that condition follows the the expression, then that statement should be the only thing to be displayed, right? So that's basically what the break does for us in a switch case, right? All right, so we move on to the operators. That's the arithmetic, the logical, relational, and so on and so forth. So let's get into that. Let me first comment this, right? So the operators. So let's see. We are dealing with the operators, and we are still going to be using the statements. That's the if statement for it, right? So I'd like to begin with the logical operators. So the logical operators, right? So that's I'm dealing with the AND operator. That's this operator known as the AND operator, and I said I'm going to be using the if statement for it. So let's initialize a variable, say age, right, to be 12. Then we terminate. Then we say if, then as you know, it follows a condition. So if the age, right, is let's say if it's greater than or equal to 18, and right, that same age, let me increase space, that same age is less than less than, say 20, or let's make it 30, right? So let's say we want to find the range. It should be between 18. So it should be greater than or equal to 18, right? But less than 30. Let's just say just some scenario. So if it follows that condition, then we instruct the compiler to display the student can vote, right? Can vote.